Artificial intelligence is remaking marketing as we speak. And if you're a marketer, you can either get up to speed or get left behind. The choice is yours, and really it's a no-brainer. Join Jeff Livingston and Greg Verdino as they explore the latest AI news, trends, tools, and ideas that are creating the future of marketing today. This is No Brainer, an AI podcast for marketers. Take it away, Jeff and Greg.
Hey, this is Greg Verdino. Welcome to No Brainer. How you doing, Jeff?
Good to see you, Greg. Happy, I guess it's Thursday that we're recording.
Yes, today is what? Thursday? I don't even know what date today is. Thursday, April 18th. So if we do mention anything that is noteworthy, newsworthy, or time-sensitive, that is the day we are recording. We don't know when this will air, but certainly it'll be sometime after the 18th. Today we are joined by a guest once again, Mr. Neil Katz from Eyelevel. Jeff, why don't you do the honors and let everyone know what Neil is all about?
Neil is somebody that I've known for about a year now, I'd say. And Neil is kind of one of these hardcore guys that starts companies like us, but he's really hardcore, unlike us. And he has a great technology company that's been working with LLMs to create private instances for organizations and companies, and has really kind of dedicated his company, Eyelevel.ai, to resolving the hallucination challenge, which, as we know, is a major, major barrier for widespread adoption. So that's why we figured we'd have him on today. But before we dive into it, Neil, hey, Neil.
Hi, Jeff, Greg. Great to be here on No Brainer. I guess I can walk in with brains or walk out with brains. You extract them.
That's why we had you come on. We needed somebody with brains here.
Yeah. Walk in with zero and walk out with some. We'll see how it goes.
For sure. Before we dive in, should we give our commercials?
Anybody who is listening, of course, please be sure to like, to share, to love, to comment, to critique, any place you are listening to us on any of your favorite podcast channels, whether that's Spotify or Apple Podcasts or anywhere else. And if you're watching us on YouTube, what do they say, those kids? They say smash the like button, and be sure to drop comments as well. We love those. We love your feedback, and we are always happy to hear what we can do to make this show as valuable as possible as it can be for you.
There we go.
Let's dive on in. Let's talk hallucinations.
Yes, but
I feel like I'm hallucinating right now.
I told you not to go to Coachella. Hey, Neil, so Before we dive into the actual questions, maybe just tell folks really quickly, like elevator pitch, what is Eyelevel.ai?
Sure. So, well, first of all, thanks, guys, for having me on. Much appreciated. And pretty simply, Eyelevel, we have tools, APIs, and no-code tools that helps companies build LLM-powered applications with their own data. So it's a kind of application where you get the brain power of a large language model like GPT. It doesn't have to be GPT, but you get the brain power of a large language model, and you can apply it to your private store of data inside your company, whether that be legal data or HR data or customer support data, what have you. And the real secret sauce, the thing that we focus on, we spent 3 years really building out, is trying to solve the hallucination issue that happens with building things with large language models. So I don't know if you've talked about in your show before or how in-depth your audience is on this issue, but language models are astounding, as we've all seen, but they have certain technical weaknesses. And one of them is they just make crap up sometimes. And they do that in a somewhat unpredictable way. And that's can be fun if you're doing creative writing. It can be slightly distressing if you're trying to cheat on your final paper in college. But when you're trying to build applications for enterprises, for banks and airlines and pharmacy, the future of what we think this stuff can do, you can't make things up. You can't hallucinate and create inaccuracies. And so we've really built a unique technology to try to deal with that. And our clients are now getting 95% accurate applications after they apply us to their data.
That's awesome. I feel like a lot of people that our listeners would care about is why a private instance versus licensing, let's say Claude for pros or ChatGPT Enterprise or another such version of one of these tools that's available, even Copilot 365. Why would somebody do a private instance? I know we have some views on that, and maybe we can riff off of what you say.
Yeah, I mean, like for the most part, when the big model companies, let's say OpenAI and Google, then there's Microsoft's version of OpenAI for enterprise. When they give you this enterprise license, what they're really doing is just saying, hey, people inside your company can use ChatGPT just like you could for $20 a month. But now the company can monitor essentially how it works. The company can have one way to bill against it and so forth. That's fine if people want to upload like a single document and ask questions about it, or if they just want to get general questions answered, just like you would if you're part of the general public paying $20 a month. That's what these enterprise are offering. I think they offer it in a confusing way to make you think it's more than that, but it's not. What we do is something different. Our technology helps you build an application, whether that application is a unique customer support app or a new legal app or a new e-commerce application, and do it based on a large store of your private data. You could load up, hundreds of thousands or even millions of pages of documents and have this really robust data set, knowledge set to work with. That's very different from what OpenAI and Microsoft are offering. That being said, we do believe these guys have great models. What we consider their language models the last mile of the application. After you take your giant pile of data and you put it in a place, securely store it, translate it into something language models will understand. There's a lot of transformation. We can get into the weeds on that later and how that helps solve the hallucination issue. And then make it available with sophisticated search to those big language models. You still need the language models that last mile. A user asks a question, you still need the language model to help answer that question, but you have to do all this work beforehand to make sure it's only using your data, only the knowledge from your company that those language models have never seen before. That's the basis for the answer. And that's why you really need technology like ours in the middle, which is very different.
What kind of success rate are you having with us before we riff off of that a little bit?
Yeah, so Air France is a customer support application, internal facing. So this is inside the contact center. Just finished the first phase of that production. They're seeing 96% accuracy.
96% accuracy. So only 1 in 25 is hallucinated.
Yeah, so that's right. And the goal here is to be as good or better than people. I mean, people, it's probably
like
not
that probably already is.
Right. That's how they view it, right? That when they're training, their point of view is, look, it takes us literally a year to train someone to answer a single phone call. Before someone at Air France can answer one call or one email or one chat, they are at least 9 months of training to try to learn the very complex information that happens inside an airline. You can bet on day one that person's not 95%. Maybe they're not even 90%. I don't quite know. They haven't shared what that is, but humans make mistakes. And also humans take a long time to find information. So that person, even after 9 months of training, if you ask there's so many things that can happen in an airline. You're going to ask a complex question. And what happens? Well, they put you on hold. If you've traveled at all, it sounds like you just came back from traveling, so you know how this works, right? You call the airline, you can take 90 minutes to get through the process.
Yep.
They know that. It's not like they're unaware. It's not like the airlines don't know that it takes a long time to be on the phone. It's just hard to solve because you call, the person answers, you have a complex question. They have to do like a kind of bad keyword search of their own documents, tens of thousands of documents, try to figure out the answer. Then they'll do it just like you do on Google. They'll read those documents. Meanwhile, you're sitting there listening to this great music, wondering if this call will ever end. In 10 or 15 minutes, they'll kind of get back to you and say, okay, I think I have the answer. Maybe they have it right. Maybe they don't. And so AI can really, really change this. And when you get to 95% accuracy, we feel that's the level where you can start to deploy this stuff at your bank teller, at your airline, at your pharmacy, in your doctor's office, the places that we all dream about, this technology will be used. But if we're honest with ourselves, the vast majority of use cases right now for these language models is like helping you rewrite emails, or maybe like work on your marketing
personal
campaign.
productivity, right?
Yeah, those are important things, but we have bigger dreams for what this technology can do, and you have to get it to accuracy before it can happen.
Yeah, I think we feel the same way, where we see those as productivity apps and not really enterprise apps, if that makes sense. It's individual productivity, and it's software you can license in an enterprise, but it's not really business grade. Does that make sense?
We agree with that, and we think the blocker is accuracy. I think that's why we see across the industry. Across the industry, people aren't really willing to admit it publicly, but the accuracy or the error rate, the hallucination rate, when you try to build these things with complex documents, is like 30 to 35%.
It's bad.
That's not leaving the laboratory. And so you've seen companies make big public announcements about the future of AI in their company, but you don't see it at the bank. You don't see it necessarily being released.
Right.
Things are stuck in the lab.
Yeah, I think
got to solve accuracy to get out.
Yeah, I think so much of the marketing around generative AI is about what these tools could do, as opposed to what they actually do, right? And I know obviously there's something aspirational in a lot of marketing, but I think so many of the promises far outstrip the kind of the current day practicalities of implementing these models in an enterprise. So that's really where what we're talking about here comes into play, because now you have, so let's say a whisper agent, so to speak, behind a human agent that's providing fast and easy access to all of this information to make the human more effective at a high degree of accuracy. One of the things that Geoff and I see all the time, it's in almost just about every conversation we have with just about every organization, is that there's still a lot of work to be done to gather and clean the data, right?
Yeah.
Very few organizations seem to have their data house in order. And for marketers in particular, that's an Achilles heel. What are you finding as you get into your client relationships are the sort of the struggles and the opportunities as they relate to getting that data house in order, and why it's so important for implementing the kind of thing we're talking about?
So I think you're hitting on something really important, which is going to be a prerequisite really for companies to be successful here with generative AI. I feel like we've spent in the enterprise, we spent the last 20 years becoming very familiar with the idea that we need to collect, clean, store, and then do something with the numerical data in our enterprise. Yeah. We're constantly collecting numbers that might be coming off software or machines if you're in the manufacturing business.
Analytics, right?
Well, you store it in a data lake and then you do analytics to it, right? You say, oh, now I've stored all the numbers in a central place in my company. Great. I've got the pipes working. Now I'm going to apply business intelligence to it, and people can see charts and graphs. Now I'm going to apply machine learning to it, and we can find efficiencies or variables we didn't know about before. That's the last 20 years. Chief data officers have risen in power and become very important, and all of that's great. None of it has anything to do with what generative AI can do.
Right.
It's almost the opposite. Now we're in the words game. Large language models are word machines. They are language machines. They don't even do math. It's really crazy that we use pure math to make a thing that can't do math. But what they are is they can liberate the ideas in your company that are stored in the smart words in conversations that happen all day long. The problem, as you say, Greg, is no one is used to recording any of that, storing it, organizing it, figuring which conversations are great and which ones are not, grading them, and creating the kind of fuel you need, the coal you need to constantly put into the engine to make generative AI work inside the company. And that's a massive. Probably like it took with numbers, we're on like a 2-decade journey, I think, to get that right.
Yeah, a lot of that has to do with structuring the content correctly, right? So that you have consistency in your documentation, so the LLM can latch around it, or whatever the AI may be, because we don't know what it'll be in the future. But making sure that it's relatively uniform, or are we just an unstructured mess?
I don't think uniformity is that important, actually. One of the great advancements of language models is they can deal with sloppy things, and really the prior generation of machine learning could not. Yeah. So back in the day with the prior generations of AI, it was a big project to like clean your data. What does that mean? It means make it more uniform, make it easier for me to put into a machine that's fairly brittle. Language models, deal with unstructured data, so you've got more fluidity there. But I'm saying people aren't even recording the content in their company. So, like, let's take for example, like who's the smartest woman or man in any department? There should be a record button at all times on that person's conversation, and use those transcripts as great training grounds for whatever you want to build, because that wisdom and institutional knowledge is coming off this person at all times.
But what about liability?
What's that?
What about the liability factor though with that too?
I think it's a great point. There's a complexity to that, which is, right. What if, who wants to be recorded all the time? It's like, who wants to be, on,
Satya,
we see what social media has done. It made a mess of when people's private moments become public. So I think you have to do it in a way that probably removes PII. You have to do it in a way that it's pretty clear when a person's being recorded or not. So they're like, they know the microphone's on or not on. You don't want like to live in a hot mic universe, but you got to find a way to get the intelligence out of some people or the knowledge out of folks and document it into something in a fluid, constant way that you're going to have great applications from it.
So let's look at a scenario where that subject matter expert doesn't mind having an always on hot mic moment, right? And we're recording every conversation that person's having. And let's say that's an ideal state, right? For the organization, if not the person, right? There's still going to be a lot of garbage in that recorded corpus of knowledge, right? The obligatory conversations about the weather and small talk, and maybe they give bad information in one example or whatever. How do we make sense of what really matters and what's right so that we can kind of ground the model in the best, most accurate information we have?
Yeah, well, first of all, you generally don't have to worry about the filler. It doesn't matter if you've talked about the weather a million times. It's just not going to come up in any kind of knowledge search. It's fine. You can sit there in the bottom of the till. It doesn't matter. Now, saying things that are incorrect, that is more problematic. And, one approach is like, look, over time, you'll say things more correct that are more often, or if you're good at your job, if you make a mistake, you will not make that mistake forever, and be then producing more of the right answer over time, and that will override some of the incorrect that's sitting in there. No database, no knowledge base is 100% perfect all the time.
Sure.
You just need a lot more of the good than the bad.
So for our listeners, let's get into the hallucination thing a little bit.
Yeah, let's be tricky.
There's a lot of dialogue about RAG databases and how they can solve everything. And I think that, and I'm as guilty as everybody, okay, let's talk about a RAG implementation. And when we get into that, I don't think business people really understand what the full implications of a RAG database are and how accuracy can be achieved with it. I know that your API does do a lot of that work. So why does RAG matter to that private implementation for accuracy? How can it be bettered to achieve the success rate that we're talking about, 90 plus percentiles?
Great question. Should we take a step back for a second and just explain what RAG is and how it works? Or is your audience...
Retrieval, augmented generation, yeah.
Okay, so RAG, which we think is probably one of the worst acronyms ever created. It's not when you're trying to brand a product. I don't know, we call it RAG, but that's what Meta did. Maybe they didn't care. It stands for retrieval augmented generation.
I'm going to name my next API Dirt.
Like if it was dirty RAG, you could really have it all.
All right, let's move on.
Yeah, no. Okay, so anyway, moving on. So, retrieval augmented generation is it's a way to build an AI application where a large language model is the brains of the application, and your data, your documents typically, is the memory of the application. And your documents, importantly, are stored separately from the language model in a server you trust. And this is really important because people don't want to necessarily take everything in their company and dump it into OpenAI's Vault or Google's or anyone else, right? You want to keep your data safe with your governance in a place you trust. Okay. When a user asks a question, what happens in this architecture is you do a fancy AI search of your data, and you attempt to find the blocks of content likely to contain the answer to that question. You then send the question and the answer blocks over to the language model, and you say, hey, language model, answer my question, but only use the content I'm giving you right now as the basis of the answer. Don't use whatever you scraped from the web in 2021, because God knows what's in there, and none of it's mine.
Especially all that stuff on Twitter.
Especially all that stuff on Twitter. That's right. So there's a lot of good in there. There's a lot of bad in there. And often it can't discern which is which. But even if it was all good information, none of it is my information. None of it is the information that's been behind a wall inside my company.
So there's no domain knowledge. There's no brand value or brand messaging related to it. There's no value proposition associated with it. It's just basically bad encyclopedia data.
Yeah.
Or good encyclopedia data.
Right.
Correct. And actually, GPT probably knows quite a bit about brands because a lot of that's fairly public facing. But when it comes to your customer service data or your legal data or your HR data or, or your e-commerce data, it doesn't know any of these things because it's behind a wall inside your company. It's your private information. Okay, so this is the way the architecture works in RAG. It's a great way to unleash the power of, a great and safe way to unleash the power of these language models on your giant pile of documents that you want to do something really smart with and now turn into like an AI goldmine. Now, the way this was originally, I think, advertised as an architecture was it was going to solve hallucinations. Why? Well, people said, well, you're now telling the language model, here, just answer something based on this pile of content I just gave you. You should surely be able to come up with the answer. And they're right to a point. The flaw in that thinking is that you have to do a lot of work on your documents, on your content, before you can get them to the place where the language model actually understands your content and what it's talking about. So RAG, in a way, can help hallucinations, but the RAG pipeline is actually generating enormous hallucinations, and most people don't realize it. Why is that? The majority of content that lives inside the enterprise exists in visual formats that language models do not understand. Language models are raw text machines. That's changing a bit with multimodal, but from a production standpoint at the moment, they are essentially raw text machines. If you feed it a pile of PDFs or PowerPoints or other things that have forms and tables and headers and footers and diagrams and pictures and a million other, even just text and funny, cool designs, it won't understand those things. And so you have to essentially convert this human content into LLM-ready data. You then have to break it into small pieces so that a language model can deal with this. You can't just give it 5 million documents to give you an answer. You can only give it so much at a time. You got to spoon feed your content to the language model. And you have to rewrite it in a way that the language model can understand. If you do all those things really well, and there's a lot of hard computing problems in there, a lot of data engineering problems in that, you get really highly accurate responses from the language model. The language model, if you spoon feed it the stuff it needs at the right moment, the language model is going to do really well. If you feed it a bunch of junk it doesn't understand, it will make things up, and you'll be confused as to why it made things up.
Yeah, I think there's a misconception, and I think this misconception is maybe exacerbated by the stories that big tech tells about what their tools are capable of, that you take a 500-page book or a 200-page PowerPoint, stick it into the model, and it's going to do its magic. Practically speaking, if I've got a PDF or a PowerPoint, it's got all the things you're talking about. It's got headers and footers and graphs and charts and tables and all these things in it. As somebody inside an enterprise who's looking to get a model to work and not hallucinate, have RAG work for me, what do I practically speaking have to do to that document?
You need to rip it apart, and you need to extract all the complicated elements and convert them into things that language models understand.
Yeah.
which is a big part of what our pipeline does. We use a computer vision model that we fine-tune in hundreds of thousands of documents that is able to say, here's the table, here's the diagram, here's the form, here are these objects. Now go extract the information from those positions in your documents and then send them to pipelines to be cured. And by cured, I mean just translated into something simpler for a language model. Like we take tables, for example. We literally turn them into sentences. We turn them into language because that's what language models want. We take a diagram. We have to explain that diagram to a language model as if it is blind because it is blind. So you have to turn it into words. So you can then do search and talk about it. So if a user has a question, the RAG system is able to search a bunch of text that describes what information happens in that chart or in that table and so forth. Now, that's what you have to do to produce enterprise real applications with large piles of documents. The good news is if you have one document, if you've got one PDF of reasonable size, and you want to ask questions about that single PDF, GPT-4 and Claude 3 Opus do a pretty good job actually now of implementing some of their multimodal capabilities to have an understanding of what's in that document. It is not 100%. There's still a lot of things it just misses, and I can explain all those details. But importantly, if you got one doc and you want to figure what's going on, it's kind of like you can just use GPT or Opus. That's great, off the shelf. If you want to build an application,
thousands of docs,
or millions, and you want to build a real application that you can be used over and over again by thousands of people, you need something in the middle to break all that down, and that's where we try to help.
So a couple of riffs on this, and their observations more than like questions. But one, it just seems to me, and I've had this feeling ever since multimodal really kind of entered the dialogue last year, that multimodal to me is more of a marketing term than a realistic capability at this point. And I think of multimedia in the sense that, because I'm an old dog, all right, that's a nice way of saying multimedia, wonderful. Mm-hmm. But the reality is what we're getting and what we're inputting, the LLM is only able to do that on the most simplistic level, right? To me, it's not really what I would expect for me to justify calling it multimodal. I don't really feel we're there yet. I don't feel like the LLMs are capable on a serious level outside that very basic use case that you talked about. I could throw a picture into GPT and say, what is that? It's got a good chance of recognizing it. I could throw my entire photo database into GPT and ask it to tag it, and I think it's just not going to happen. So that's just my take on it. Yeah. But the other thing that it comes back to is our original conversation, which is preparing your data, your content, your unstructured data for consumption. You know, it gets back to garbage in, garbage out. You know, it doesn't matter how powerful the tool is if you don't have your house in order, if you're not ready to really invest in cleaning this up, it's going to be problematic. And I think one of the things, and I want to see what your take on this is, and maybe we'll get back to an interview instead of a rant.
Yeah, sure. No, just rant on, man. Burn a house down.
Yeah, let's burn it. Right. So it's governance, right? Like, how many organizations now need to think about governance? You know, how are you building your data today? How are you building your content? Yeah. How are you creating this information? How can you do it so that regardless of what's happened in the past, everything moving forward is ready for whatever may come down the pike? What are your thoughts on that?
Well, first of all, I will say that, look, we built our technology to deal with a world of dirty documents and dirty data. So it's not like you're stuck on a 2-year project if you've got PDFs or PowerPoints or other things that are hard for language models to digest. We're pretty good at handling almost all of it. There are edge cases, but if there are, we tend to re-ingest and fine-tune our ingest models based on unique things your company may have. So I don't want people to feel like they should be terrified.
It's hopeless. You're doomed.
It's a hard problem, and I don't know that anyone's really worked on it as much as we have. So if you don't, it's hard to do it yourself. I will say that.
Yeah.
However, I agree with you that going forward, it does make sense to produce things with an eye towards them being easier for language models to understand. And, you know, I don't think I've talked to a single graphic designer yet who's thinking this way in terms of how do I make something that's pretty for humans and also more understandable for LLMs. And also, how do you do things in more digital formats that have markdown inside? I'm going to get a little techie here for a second. The one of the core problems with these documents is that they're built with the technology, like PDFs in particular,
right,
of which there are billions and maybe trillions of these things in the world, storing an enormous amount of great ideas inside of them. They were a brilliant technology to solve a really hard problem from more than 3 decades ago.
Which is copies, digital copies.
Well, it's basically that how do you, when you're looking at something on my computer screen or on your computer screen, how do we get a printer to reproduce the same thing consistently, whether it's on your screen or my screen or your printer or my printer? And they came up with this language called PostScript, which pretty brilliantly I was able to standardize how elements are created and then recreated on printers. It's a printer language. What they forgot to put in there, because they weren't thinking about it, was anything that described to another computer what was actually inside the document. And so when you make PDFs, it doesn't describe like this is a table, this is a form, this is a diagram. It doesn't describe what's in it.
No meta.
And so now we've got this giant backlog translation problem. Something similar but different has happened in the more modern era, where let's take example a web page. Okay, now in theory, a web page should be very easy to ingest into a language model. Why? What has HTML? And what is HTML? It's kind of a markdown type of language, which is describing to a browser or to another computer what it is. This is a table object and it has these things in it. Here's the header 1, here's the header 2, here's the header 3. Telling you page hierarchy. The problem is that a large percentage of web pages in the world, or any other kind of modern markdown, isn't done with any rigor or precision. And so now you've got all this new content that should be pretty easy to understand, but the markdown's all wrong. You haven't who implements like a really tight, markdown language inside their companies to make sure everything's completely consistent. That just doesn't happen, right? And so now we've got weird and bad data rather than having no data. And we have this new problem again. Anyway, we try to build things to solve these problems. I think compute will get us out of the mess we've made for ourselves.
Very cool. Another question for you. We keep hearing about open source and why some particularly more regulated enterprises, financial, for example, medical, government, it may be more valuable for these guys to use an LLM that's like open source, such as a Llama or a Mistral-based one, only in the sense that of all the security issues that they may anticipate using OpenAI, for example. What are your thoughts on open source versus these more proprietary models and how they stand within this larger LL game?
So right now, the closed source models like Anthropic and OpenAI are better.
Right.
It doesn't matter what standardized testing reports people put out about these open source models to us that much. In the real world, which is complex cases, these closed models they just perform much, much better for general purpose use. So they have a lead on performance. But to your point, Geoff, I think there are many industries, typically regulated ones, banks, healthcare, airlines, others, where the performance of the model is important, but probably secondary to being able to completely control and trust and host the model in an environment that you have your eyes on and have data governance over and observability over. So when the government comes knocking and said, hey, Citibank, why did you tell people this? You can trace that back from answer back to the root machine. And I think the regulated guys will have a really hard time dealing with black box software. And, the government's not going to accept, oops, I don't know, I just outsourced the problem to somebody else. I don't know what happened.
Blame Apple.
Yeah. So that's one piece. But now I do think, though, And so I think open source is going to have an important role, and I'm glad it's moving so quickly to try to catch up. The other maybe piece, though, is that at the moment, people are maybe people who are like a step down from a bank, right? Maybe it's important you get things right, you want observability, but the government's not after you all the time. For them, those companies have gotten very used to the idea that they can store their data on a cloud from Microsoft or Google. Now it's a managed cloud, so they feel like they've got some kind of control over the security parameters, but ultimately it's basically hard drives on machines in buildings that they don't own or control.
Correct.
They've moved from on-prem, where everything was on hard drives you physically bought, in racks you physically leased in buildings you may own or at least lease, to cloud. I think there'll be a version of that with these large language models, where companies like, say, Microsoft, well, you're hosting my documents over here, and I trust you with your database technology to process them. That's kosher. So why don't I trust you to process them with a language model? So I think it'll be a huge piece of the economy that's totally fine with that.
Right.
But the most regulated folks, I think, need things that are completely have observability, from beginning to end.
Do you think the horse race will get a little more even? I know that we're looking at another Llama release and there's all that stuff. Or do you think the horse race is kind of, at this point, tapering out, that we're hitting our capability levels?
No, man. I think we're not even. This is like the first inning of this whole thing. At the moment, everyone's more or less using the same architecture, the same concept to build these models, and it becomes kind of a fight over the training data and a fight over the human reinforced learning with human feedback, which is something that people don't talk about a lot. But one of the reasons that OpenAI has this great advantage in the real world is that they have thousands of people, maybe tens of thousands, not clear, I don't know, they didn't talk about it, that are grading the answers that come out of these machines all like 24 hours a day. They hire, it's like in Africa and East Asia, and these folks just going good answer, bad answer, good answer, bad answer. That's a very human-in-the-loop process that makes these machines much more refined, and makes them a lot better. It's very expensive too. So there's a lot of combination between the architecture and the reinforcement learning to make them better. That being said, there's an entire universe of audio, visual, video data that has barely been consumed, which will make these models much more interesting. And there has to be yet new innovations of new architectures, new ways of doing the learning to make them smarter. I mean, at the moment, they're still kind of dumb word machines. They're brilliant, but they don't really have a world view, a model in their head of what's going on. And they can't even do math or science or engineering, which is what we really need them to do. So I think we're just it got everyone's appetite wet. Wow, AI can actually be really good. It's not just like giving me a better Netflix recommendation for which movie to click next, which is, I don't know, interesting, but not really. I think we're just at the beginning of this thing.
I never take Netflix's recommendations. They're terrible. Just kidding.
The other piece of puzzle, by the way, is the physical architecture of this all, right? I mean, at the moment, doing these things is insanely expensive. They all take a huge amount of compute to train the models, then to run the models, which is called inference. There literally aren't enough GPUs in the world to process all the AI we want to process right now. I think there's another generation of hardware architecture to come that makes that more efficient to run, and just like with cloud computing, with everything else, eventually they find better, smarter ways to do it. We're just at the beginning of the race. It's going to get interesting.
Very cool. I don't have any more questions. Great. Do you have more?
Well, since we're talking about, since your perspective is, not surprisingly, that we're just at the beginning of the race, if you kind of put on your tinfoil hat or whatever, and think 3-5 years out, what do you think this looks like in terms of not the gears and grinds technical stuff, but what might a business be able to do a few years out, the way you see this technology evolving?
There's a big scientific question with large language models, which is not currently answered. The question is, can they expand beyond just simple language? And a corollary to that question is, or can we translate things that don't seem like language into language so that language models can then process them? So What we really want is AI that can work on the hard sciences. We want new rockets. We want spaceships that go faster than light. We want drugs that cure cancer. We want to build skyscrapers that are 6 times bigger than the ones we have today, but take one tenth of the energy. Language models can't help you with any of that today. And people just think, oh, it's AI. It's going to do anything. No.
Yep.
It's a word machine. Now, can we shift this to also be an engineering and math and hard sciences machine? That is not clear. I think for the things that are easier to make into a language, we've got a very nice path. Like if you think about DNA, it already is a language with basically 4 letters, 4 chemicals. So that seems really interesting. Can you do the same thing with physics? I don't know. But if you can break that through, then potentially you're living in an exponential age where, instead of a hard science invention every 20 years, it might be every 20 minutes. We think we're living in a fast-paced world. I think we are not. You're still flying in an airplane that was designed in the 1960s.
Right.
Cars, maybe the electric you could say has changed somewhat, but still the same car more or less. It still goes the same speed, still just about as safe as it used to be. Electric is cool, but it was invented 100 years ago. Now we're bringing it back. Like, the things in our physical world have stalled. We took men to the moon in the 60s. We still can't figure out how to get back there.
It's crazy.
Elon Musk's brilliance aside, he's still trying to figure out how to get a rocket there. NASA did it in the 60s, and so did Russia. So there's a lot to go. Can we get to a real exponential age? Maybe. And if we do, that is unbelievably exciting. And then you'll look at the amount of change we're having right now as absolutely nothing's going on. It's like we're standing still.
Do you believe LLMs get us there, or do you think we're looking at some fundamentally different architecture or combination of different models that work together to get us to solutions to climate change and curing cancer? And
I think it's probably a combination of models. I do feel like there's some leap that's needed next to do the real hard sciences, but I think some of them, maybe like DNA and things, could actually be turned into language and do quite well, and that would be very exciting.
Sure.
But to make rocket ships, you probably need some new architecture. The other thing I'll say that could be very interesting, happening very quickly, is robotics merged with LLMs. Those guys are getting pretty good, and when you take a robot that can work, that can handle the physical world decently, and merge that with a language model so you can talk to it, that suddenly feels like magic. You feel like you're dealing in a completely different world. And now you've probably seen those videos on the internet just as I have. It's not what we do, so I don't have deep domain on it, but that feels like it could have its ChatGPT moment very quickly.
Very cool. Very cool.
All right, awesome. Thanks so much for all of this. I think we've covered a lot of ground, everything from RAG databases to robotics. Robotics certainly have better branding than RAG. I think we can all agree on that.
Should just call it dirt. Dirt.
There's a better name, but there's a lot of sci-fi bad branding around robots, and they got the Terminator to deal with in terms of putting one of those in your house.
I still think calling this whole technology movement AI was whoever was thinking about this in 2017 and 2018 when they started hitting the marketing push pretty hard on it. Could have gone a different route.
You ready for a rebrand?
I'm ready for a rebrand because I personally, maybe I'm too grounded in historical science fiction because I loved reading it when I was a kid, but I definitely think the whole AGI angle is what I think of it with AI, and I just feel like we've misappropriated the name for this technology movement, but that's marketing, right? Marketing does that to everything.
Well, it's been an aspirational field really since the 60s. I mean, when
Alan Turing, right?
It's a philosophy, right? It's a philosophy as much as it is a technology, the idea that we can make a mind. But I think for people who didn't know any of this stuff existed until whatever it was, November 30th of 2022, which is a shocking number of people, calling ChatGPT AI which it is technically, right? But calling it AI and branding it that way, I think, has led people to grossly overestimate what that tool is capable of. And where you
Yeah.
get a lot of misunderstanding among regular business people who all of a sudden think that they are in fact
Talking
playing
to
with
Hal.
magic, right? Yeah, talking to Hal when they're just kind of
Yeah. Well, look, OpenAI has done no favors to that. The CEO of that company, basically says every day the goal of their company is not ChatGPT, it's AGI.
right.
He's like, yeah, I gave you a chatbot, but I'm trying to build Terminators. It's
I
basically
wonder. I wonder what his goal is. I think it's just become famous, but that's me.
Well, it's rich and famous, right?
Yeah.
But I actually think it's something deeper. I know you're going to run, but I'll make it a 10-second rant, not a 10-minute one, which is that to me, AI, whatever you want to call it, is just the latest installation, latest chapter in a 250,000 year cyborgian journey of our species. Starting literally with the wheel. I mean, we're constantly making machines that augment and multiply the powers of our body.
Mm-hmm.
And we're very used to the idea that a forklift your thumb can move 10,000 pounds now.
Right.
We're not used to the idea that your brain can have 10,000 ideas
Right.
and be augmented in that way. And so it feels very alien, but maybe as alien as the birth of the steam engine did back 150 ago.
Well, I think we can officially say we've buried the lead here.
I think we all got to watch 2001 though this weekend.
To the very last minute of the podcast. But Neil, where can folks find you and Eyelevel.ai if they'd like to learn more?
Sure. Well, the company's website is Eyelevel.ai, and Eyelevel is like your eyeballs, so it's EYE level.
It's spelled right.
We didn't use internet spelling. We didn't take the vowels out. We tried to use real words. So that's where you could find us, and I'm easy to find at Twitter. Just my name, Neil Katz, and you will find me.
Well, we wish you the greatest success. You're a good ally and a brilliant mind, and the market's lucky to have you. So
Very kind of you. Thanks, guys. Appreciate it.
All right.
Awesome. Thank you.